Forging press, definition, types, uses, advantages and disadvantages. A forging press uses an upward ram to apply consistent, controlled pressure to a die holding a workpiece. It is a similar process to drop forging, however, it utilizes slow pressure rather than a series of blows. Types of forging presses. 1. Hydraulic forging presses. Hydraulic presses create their force through hydraulic pressure from a liquid utilizing Pascal's law. The force of a small amount is applied to the fluid, which moves a bigger amount of fluid to create the force that further moves the ram to shape the workpiece. 2. Screw forging process. A screw press, similar to a hydraulic press, works slowly. A screw is turned by a motor that further pushes the ram down onto the workpiece with a pressure that is steady and with a long stroke. 3. Mechanical forging presses. The motor and controller are driven by mechanical forging presses. It also has a clutch and crankshaft which are equipped for applying a consistent stroke length to the ram. 4. Pneumatic forging process. The force of a pneumatic press comes from compressed or compacted air or gas, which is constrained into a cylinder connected to a ram. The pressure from the cylinder forces the downward movement of the ram only when the cylinder is filled precisely. 5. Servo forging process. A servo motor or engine that drives an eccentric gear makes slider movement and is basically driven by a servo forging press. The main thrust created or conveyed by the motor is changed into direct development by screws, turning bars, and elbow pulls to drive the slider. 6. Upset forging and upsetters. Horizontal forging, which utilizes upset forging and upsetters and afterwards the machine that moves horizontally utilizing a ram against the workpiece. The workpiece is held set up between bite die halves while pressure is applied toward its axis by a heading tool that spreads, or upsets, the end of the workpiece by metal displacement. What are metals used in forging presses? 1. Steel. 2. Titanium. 3. Aluminum. 4. Stainless steel. 5. Brass. 6. Magnesium. 7. Copper. Advantages of forging presses. A. Strength to weight ratio. During the process of forging, the grain structure of the piece becomes compacted, which creates diminished stress on the corners and fillets, growing the strength of the piece. B. Post-forging treatments. With a shortfall of voids and porosity, pieces can be machined in the wake of forging without a loss of dimensional exactness or quality. C. Reduce defects. D. Cost savings. E. Higher productivity. F. Die lifespan. G. Produces complex designs. H. Mechanical properties. Disadvantages of forging presses. A. Cost. Tools and dies for the process must be specially made utilizing a select number of metals. B. Dies. Forging press dies are costly and hard to make for complicated parts. Highly complicated parts and designs can't be produced utilizing press forging. D. Amount of force. Heaps of pressure are critical to form a section in a forging press, which requires large and costly equipment. Conclusion. There are a few strategies for creating a force for a forging press, which incorporates mechanical, hydraulic, servo, and pneumatic. The process of a forging press is quicker and more affordable than other production methods. Thanks for watching.